have an idea of substance, okay? Because a lot of people have different ideas about substance, and a lot of people have what I think of as incorrect ideas about substance. We'll discuss some of them as we go on. And we need to have a realistic idea for all kinds of things. So I'm going to propose a general idea of substance that can be used in slightly different ways, but for physical things, mental things, spiritual things. And it will be based on what I say here as the propensity or power or dispositions of things. So I'll explain why that's a useful way of looking at substances. And in particular, I want to introduce the idea of mental substance, because there's been a lot of debate in philosophy and literature and even among religious people about what mental substance is. And so I will discuss some ideas of those which I think are good and some which I think are not so good. So we'll come to that. And at some point, I'm going to come to what I think of as punchlines or thing to remember. So I'm going to use this little symbol here, a star and a circle, to point out things that may be useful for you to remember, specifically these things, because they'll be useful in debate when you're talking with people who want to understand what minds are, or when they say, whether people say minds are just the brain or whatever. So the first thing to talk about is substance. And now I'm going to start by I'm going to distinguish three things: substance, form, and dynamics. And some of these things are stressed in Swedenborg and some from physics. So, but I want to, this involves, the next couple of slides involve some sort of systematic thinking about what things can really exist. Because I claim there are three categories of terms in science, or also in theology for that matter. The first thing is formal terms, the forms of things, the structure of things, the properties of things, whatever exists now. If you were to look at something, you would see its form. If I look at the chair, I see the shape of a chair. I can't tell what it's made of, I can't tell what it does, but I can tell that it's the shape of a chair. So this is like the manifestation, or the existere, as Swedenborg puts it. This is what's manifest and immediately obvious. That's the first thing we need to know about something. The second thing is what exists. If I look at the chair, I want to know what it's made out of. What's the substance of this chair? And then the question is how do we tell what the substance is? That's the question which I want to answer. And the third thing that we need to know about a chair or a person or anything is its dynamical properties. This is what science in particular is interested in. It wants to make predictions how things would behave, what would happen in new situations or hypothetical conditions. So an engineer designing a new building might put material in a configuration that it's never been used before, but if he knows the dynamical properties of his materials, he can predict how the bridge or the building will stay up by using science. And if you only knew the shape of things and what things existed, you wouldn't be able to predict that. So any scientific explanation requires also these dynamical things. So only by dynamics can we make predictions. So these three things, these three categories, I'm going to produce some more examples from science. So when we say form or existence, we have this long list of things here: shape, numbers, functions, fields, oscillations, vibrations, waves. The font is a little small there. Or numbers, anything to do with mathematics is in that section, in this category of form. These are the things that's manifest to start with. And mathematics can tell you immediately what's happening, but it only tells you what you can see, what the shape is that's there. Are you okay there, Gloria?
Yes.
Yes? Okay. And then the second category that I listed was existence. What exists? And we can see here words like particle, material, substance, matter, corpuscle, or fluids, or reality. All of these things talk about what exists. But the trouble is that if you just know what exists without knowing how it behaves, you don't really have much to go on. So this is the question of ontology. Ontology is the science, so to speak, of what exists. And the third category is the dynamical category. So, and this is the question of physics or dynamics. Psychology is also interested in how people behave. And you can see where I'm coming to in a minute. We need all three of these categories, because if you just have form, it doesn't tell you what exists and it doesn't tell you how it behaves. If you just have form in existence, it says that there's a shape here that exists, material shape that exists, but it doesn't tell you how it behaves. And if you just have properties, so you just have dynamics, you want them to exist in some way. In other words, you can't just have forces by themselves without anything having the forces, without something existing.
You mean form in the sense of an ideal cube or something?
Well, not just an ideal cube, but an actual cube. It could be some funny, weird shape. It could be an irregular shape, but it has a shape. The chair has a shape. It's not a cube. It's not a rectangle. It's some interesting shape. And computers are very good for describing form.
But the shape is separate from the actual substance.
Indeed. Normally we think of the substance has the form, or there's a substance in a form. See, computers, for example, are good at shapes, and they're good at describing changes, but there's no substance in computers. There's no existence. So you can see that virtual worlds are form with moving forms, so they have dynamics and they have form, but they don't have the substance in the middle. So you need all three of these in order to have a proper understanding of physics and a proper understanding, I will argue, of psychology and even a proper understanding of theology. So I'm going to say that we need to have an idea of substance. But the trouble is that it's difficult to form an idea of substance. So what I'm going to do is to use dynamics, use the dynamical properties of something to define what its substance is. Now, this may seem obvious to some people, but it's not traditionally done in science by people who think that they understand. It's done in practice in science, but people who try and understand science don't like this idea so much. And this idea that I'm going to put here is that the substance of thing is its propensity to do something. In other words, if we go back to this previous page, oops, where are we? If we have all of these three categories here, we're going to use all of these ideas to derive what existence is. In other words, I'm going to say that something just comes from what it can do. And this may seem inadequate, but in fact, it's used a lot by lots of people. And I'm going to show how it's used. When we talk about an electromagnetic force field, a radio wave, for example, is an electromagnetic force field. It carries energy from the transmitter to the receiver. The electromagnetism describes the dynamical properties, and the field, whatever shape it has, radiating away, is the form, which is described by mathematics. And similarly, we have a potential energy field. We think of the gravitational field of the sun in which the Earth rotates and keeps the Earth in position. This is a gravitational potential energy, and this is a field. And so energy is like the dynamical properties, but we're going to say that things are made out of energy. Now, this is rather obvious now, in fact, but it took a long time for this to be acceptable, because now we're so used to Einstein saying that matter is a form of energy. This is commonly accepted now, but 100 years ago it was very difficult to understand, this E equals mc squared. This is the relation between mass and energy. So, but by now we accept that matter is a particular form, it's a particular kind of energy that is designed to behave in some ways. So an electron has electric charge, and it has mass, and it has magnetic field. And now we come to quantum mechanics, because quantum mechanics is what we normally think of as the best way of understanding physics these days. This is my day job, is to do quantum mechanics. So I'm going to show some ideas which I have from Swedenborg, which will help me to understand what quantum mechanics is, and I'm trying to understand that a bit better, because we'll show in a bit more detail later. But in quantum mechanics, we have a wave function, an oscillatory wave function that propagates out, and it produces random events. And so the question is, how you understand that in a realistic and scientific way? And so I'm going to say that the quantum wave function is a propensity field. It's a field of propensity. It's a propensity to interact, to make a measurement or a selection or to localization. It's a propensity to choose an actual outcome. And this is in the same way as we have fields of substance. Now, you have to remember that propensities are still present even if they're not acting. So the gravitational field of the sun is still present even if there's no Earth going around it. So in other words, the gravitational field persists through time, and that makes it like the energy of the gravitational field is like something that's existing. It carries energy. The gravitational field carries energy. And I'm going to now argue that we don't need anything more to existence than the set of all the propensities for what it can do. This is called, in philosophy, the Eleatic principle. A thing is known by what it does. This is the same principle we're using here. Now, it may seem that I'm giving away too much when I say a thing is only known by what it does. I'm saying there's no such thing as the hidden nature of an electron that produces all its properties. I'm saying that the electric charge and the magnetic effects and the mass, the gravitational mass of an electron are just what an electron is. And the reason is that this is also useful in theology. So, now first of all admit that I said this is a new idea, but it's actually Aristotle, even Newton had some ideas like this. So we'll see in a bit more what Aristotle was up to. And so by means of this idea of a substance that's composed of all its propensities for action, we can also look at mental substances, because I claim that this works for minds, because traditionally we haven't understood what minds are. We don't know what a mind is. We think of it as something we know not what. You know what I mean? Descartes said it was rationality. Other people say it's consciousness. Other people say it's something strange. But what is it? But now I'm going to take a rather simple idea of what minds are by saying that mental substances, those things of which minds are made, are just the propensities, the propensity for mental actions. In other words, their loves and desires are the substance of which minds are made out of. In other words, love is the substance. And another word for propensity is dispositions. And Gilbert Ryle, 1949, wrote a long book. He thought he was writing a materialist book in which he said, minds are nothing but the dispositions to act. But if we take dispositions as referring to real substances, then I agree with him that minds are dispositions. He thought they were physical dispositions, but now I say you can form an idea of mental dispositions.
When you say minds, is that to be understood as thoughts?
For example,
Right.
we'll come to what thoughts are in relation to these loves and desires. And in fact, one of the encouraging features about this is that Swedenborg also says, as he said, divine love and wisdom are themselves substance and form. In other words, love is like a substance that makes things. And so I think this principle of love being a substance, or the substance of minds being love and desire, is a very general thing which can be very useful because it explains exactly what minds are. They're made out of desires and loves. And we know we have some acquaintance with our desires and loves. And so therefore we begin to have some basic ideas of what minds are. And so the question then is, what are they loves and desires for? So there's lots of different loves and different desires we could look into. But once we have the basic idea that physical things are propensities in a certain form, and also mental things are propensities in a certain form, mental propensities, then we have a general principle, a general understanding of what minds are, which is very useful. And as I said at the beginning, the idea came from reading Swedenborg first. He said that love is the substance of man. I'm not sure he said exactly that, but this is what I remember.
Would you call intention a mental propensity?
Yes, it's one of the mental propensities. There's a lot of thought component to that, which is Jim's question. An intention has a specific idea in mind, whereas a love doesn't always have something in mind. So we'll
love prior to its descending into thought could be called mental energy. I mean, I've experienced mental energy before it descends into thought.
Yes, we'll discuss later the difference between love and energy. So if we look at, if we use this idea of mental minds being composed of love as a substance, then we can look at various other ideas that have been proposed historically, and we can get some idea how good they are. So I'm going to list some what I call bad ideas about mental substance. Thomas Aquinas, for example, said that the forms of things were minds, were the substance, were mental. So if we go back to our list of 3 things, form, existence, and dynamics, only the first column, he would say, if it was immaterial, would be what a mind was. But then that doesn't give us any substance, it doesn't give us any dynamics, so that's clearly inadequate. René Descartes said that mind, res cogitans, a mind was a thinking substance. And that's beginning to be a bit better, because thinking is one of the motivations which goes on in our mind. But I think loves and desires are a better description of this underlying structure of minds. And thinking, to answer Jim's question, is one of the intermediate products of mental action before it becomes action. And then more recently, matter has been taken to be the substance of mind. They say our minds are just brains, and this is what's been adopted by the materialists and the physicalists. But that's the wrong. Matter is a propensity, because everything that exists is a propensity in some form, but it's the wrong kind of propensity. It's a propensity for physical actions, not for mental actions. So you still have to work out what the desires and loves and propensities are for. What are they trying to do, so to speak? David Bohm had an idea that minds are related to information. But this also was a problem, because information is still the first of those 3 columns. It's just the form and not the existence or the dynamics. He realized that was a problem, so he talked about active information. But active information still doesn't say what exists, and it doesn't tell you what would happen. It just says that something is happening. But we still have minds even when we're not doing things, and even when we're not thinking, so to speak. Our love is still present, even then. Other people I mentioned last week had this idea of quantum vacuum. There's a hidden layer behind the physical which is present all the time and is responsible for the production. And they think of this as sort of like a spiritual dimension. But the trouble is, quantum vacuum is from quantum mechanics, and that's physics. It's the wrong kind of propensity involved when it comes to doing things. And finally, a popular idea of consciousness is consciousness. We think of God as pure consciousness, or they think of, when people want to know about minds, I have my consciousness. This is who I am a consciousness. But then the question is, what does consciousness do? And this question of what consciousness does has been bothering philosophers for a long time, starting with David Chalmers, who said that, if consciousness doesn't seem to be doing anything, there's no dynamical properties that follow from consciousness. It exists in some sense, because we can tell if there is or isn't consciousness, but there's no dynamical properties. So I will come back to consciousness later, because clearly consciousness is an important part of minds, but I'm going to say that consciousness is the mode of operation of love, rather than the substance that things are made out of. So the question is, by now, having this idea of substances made out of propensities in some form, you should be able to take these ideas. If someone presents you an idea of minds as made out of one of these things, you should be able to understand why these are not satisfactory ideas of minds, or what minds are made out of. Now, I've been talking about minds, but I'm going to come back to quantum physics, because I like quantum physics. And in quantum physics, I want to show here. Now, some of you will have had an understanding from Swedenborg about love being a substance. So I'm now going to try and get you to use those ideas to understand quantum physics, which is not the usual way of teaching, but it might be useful in your case. So in quantum physics, there are random events. That's the feature. Radioactive decay is a random process that spontaneously goes at random. And this radioactive decay comes from a wave function which is spread out in space. And furthermore, so here's a little picture of a wave function. And furthermore, this wave function comes from a solution of what's called Schrödinger equation, which is an equation about energy. This energy is kinetic energy plus potential energy, if you remember. And so Schrödinger equation says that the total of kinetic energy and potential energy produces a time change of the wave function. That's just a sort of verbal summary of what this basic equation in quantum physics says. And so if we come to the way we understand now, we're going to say that this wave function is a form of propensity. The propensity is for probabilistic events. So whenever we talk about desire or love or propensity, we have to say what kind of love or what kind of desire, what kind of propensity. We have to say what it's for. So in quantum physics, propensities are propensities for probabilistic events or selections or choices. The electron is going to one way or another. And now the principle that I just had was that this propensity is the substance of a quantum object. So this little picture here shows a quantum object that's spread out in space. So there's no specific very small particle. There's no point particles in quantum physics. There's only waves of various sizes. Sometimes they're small, sometimes they're big. But in each case, we have a wave and a wave of propensity. Normal physicists say it's a probability wave, a wave of probability, or probability amplitude. But a probability is a number, and an amplitude is a number, and a wave is describing a number. So to say something is a probability amplitude is to only give something from the first of these three columns. It's only to give the form or the shape or the mathematics of it. It doesn't say what exists or what happens. So what I'm saying here is that the propensity is the substance and the wave is the form. And this is an understanding of, whenever we look at things in the future, I want to argue, we should look at what the substance is, which is its propensities, what it does, and we should also look at the form it has, which is how it appears. So if we go back to the example of a chair here, we can see the form by looking at it, and the substance of the chair is defined by all of the ways in which the parts of the chair will interact, its propensities for interaction. And I'm claiming there's no other hidden substance behind there apart from the parts and their propensities. And the task of science is to understand what the parts are and what their propensities are in general, whether they're physical or mental, whatever they might be. But if we go back to the top of this slide here, we said that I talked about a wave function spread out in space, and it comes from a wave function about energy. This is interesting because it means there's a bit more detail about discrete degrees going on here. There are what I say are two stages of operation in quantum physics. So we have actual outcomes, which are where the electron hits a particular photographic plate, a measurement. And then we have the wave function, which produces that according to what's called Bohr's probability rule. And then we have, okay, that's Bohr's probability rule. And the actual outcomes are selections. And then we have this active energy, this sum of potential and kinetic energy, produces the wave function, and then the wave function produces the outcome. So this is, immediately we see that there are more than two discrete degrees. Here there are three discrete degrees, and we'll see later on we'll come to many discrete degrees. So I'm saying that even in simple physics, there are many discrete degrees, and this helps us a lot for those who are interested in these things to understand what discrete degrees are in Swedenborg, because Swedenborg also has many discrete degrees. And furthermore, if you look at, I haven't said so here, but the the next actual outcome depends on the propensity wave, and the propensity wave depends on the previous outcome. So there are boundary conditions in the production there are selection rules, and we'll see the structure of this in more detail later. So I think this is just a summary of, yes. So what I'm saying here is that energy and propensity are two different kinds of substance. There are two different kinds of substance in this case. There's energy, which we think of as a substance, E equals mc squared, it's like mass, matter, but there's also this propensity for producing things, and that's produced by the energy. So in quantum physics, there are two stages of operation. And for those of you who want to think about this from a Swedenborgian point of view, this is like sort of spiritual and natural and then the final effect, okay? One produces the second and the second produces the third. This is the sort of a sequence there. But in this case, this energy and this propensity, neither of them are mental propensities. Now, if you go back historically, James Jeans said that when he saw quantum mechanics, he said that the wave function looks like the operation of a mind rather than matter. And many people have taken the existence of a wave function spread out in space as indicating something mental. I agree that it's one discrete degree above these actual effects, but it's still a physical degree. We'll see later what mental degrees are. So here we have discrete degrees in physics. And furthermore, other people have said that energy is the hidden spiritual nature of everything. But here, energy is still described by quantum physics. We'll see later that there are many more degrees than that. And that's where the spiritual and mental things are. Jim?
When you say in number 4, two kinds,
yes.
The way I'm looking at your diagram, I'm seeing a causal pattern left to right.
Yes.
So I'm wondering if that's two stages.
Well, you can call it 3 discrete degrees or 2 stages of operation.
Yeah.
We have to think of our terminology.
But I mean, there's a causality.
There is.
There, so that they're connected across the discrete degrees.
Yes. So the discrete degrees are not independent of each other.
They are two kinds, and there are also stages when they're...
They operate, yes. Energy is continually producing the propensity wave, and then the propensity wave produces actual outcomes occasionally. So there's different kinds of structure involved in this.
Aren't all these all on the level of matter, though?
Yes, exactly. They're still in physics.
They're all the same degree.
Oh no, but they're sub-degrees of the physical, okay? But so far I haven't...
They're not really discrete if they're all on a continuum.
No, but they're not a continuum because these are qualitatively different. Energy is qualitatively different from propensity for probabilistic events, and probabilistic events are qualitatively different from waves, okay? So that you've got to think of many possible discrete degrees, okay? They're still discrete degrees, but they're sub-degrees or sub-sub-degrees, or will come in the next lecture. You'll get an idea of what's going on here if you're here, okay? So this has been my understanding that I've reached of quantum physics using ideas from Swedenborg, okay? So it's an interesting, this is one of my favorite hobbies, and I wrote a paper about this 20 or 30 years ago, 1988, in which I talked about these propensities. I called them real dispositions. And if you look at that, you can distinguish some bad ideas. Again, I'm going to list some bad ideas about quantum mechanics, which you may have heard about. My colleagues have this, what they informally call the shut up and calculate philosophy. In other words, it's just used for predictions, and if it predicts the right thing, then that's good, okay? But this doesn't tell you anything about what exists in the quantum world. It doesn't tell you what electrons are made out of, or atoms, or brains, or anything. So not many people, they do this during the day, but it's not exactly a lifetime way of looking at things. Niels Bohr had a rather different idea of what existed. He thinks just the final thing on the end, the actual outcomes, were real, and the two previous things were just ways of predicting the actual outcome. So at least he had something existing. He had what's called classical observations, or actual measurements. He had them existing, but not the two earlier ones. He didn't attribute any reality to the wave function or to the energy involved. So that doesn't tell us what propensity or substance is. It doesn't tell us what exists between measurements, for example. Only the measurements are real, according to him. Another one you all have heard about is the idea of a splitting universe. Every time you have two options for making a measurement that are both possible, then the universe splits into two copies. So this has the first two stages. Actually, at the bottom here, I have these three stages. According to parallel universes, we have the Hamiltonian producing the wave function, but the wave function keeps splitting forever and ever. There's no selection involved. So it only has the first two and not the third one. So that's, nothing actually happens in the parallel universes theory.
This is Nicholas Everett?
Yes,
I don't know. Well, keep going.
Yes.
I don't understand what he's saying.
No. I'm not saying that you have to understand it at the moment. I'm just saying that if you look into it, you'll discover it's not a very good idea. And many physicists have come to that same opinion. And just for completeness, well, one of them. David Bohm had an idea that there was a hidden classical particles that were governed by the wave function. And I list the difficulty of that view is that this middle wave functions are not really real in any sense. They're just calculational devices for guiding these hidden particles. It's also called the pilot wave theory. De Broglie postulated something like that. So this is an idea in which there are energy and there are actual outcomes, but there's no wave function in the middle. So I'm saying that a proper understanding has all three of these components and doesn't try and neglect any one of them, because if you neglect any one of them, you get one of these I call bad ideas about quantum physics. But I claim that we know from Swedenborg that things occur in trines or triplets, so that we should expect this pattern of A to B to C occurring. And then finally, Eugene Wigner suggested there was selection by consciousness. I say, first of all, that these propensities I have are propensities for selections. And so therefore, they're not mental propensities. But it's still, and then I leave it open, but maybe when. Henry Stapp here at Berkeley suggests that consciousness decides when the selections occur, and that's still possible. But it's certainly not quantum waves are made out of consciousness.